I'd like to introduce our moderator for the cybersecurity panel. This is Kelle Wendling of Harris Corporation. She's the Vice President and General Manager of Mission Networks. She oversees managed networks, surveillance and global aviation solutions, as well as new market initiatives such as unmanned aerial systems. Prior to her current role, she held positions as Vice President of Business Development and Strategy and the Vice President and General Manager of Intelligence, Surveillance, and Reconnaissance Business. So Kelle, I'll let you introduce your panel. Thank you very much.
Thank you so much, Al. As Al said, I am a recent addition to the aviation industry. I have a few years' experience of it in a previous time in my career, but I spent most of the last decade in our intelligence, surveillance, and reconnaissance business for Harris Corporation. Surveillance in that kind of nomenclature means a little bit different than what we do for surveillance in the air and the NAS for the aviation community. But that being said, I'm probably responsible for some of the content we're going to talk about today for cybersecurity, meaning the kind of intelligence, surveillance, and reconnaissance we do are probably responsible for some of these vulnerabilities and products and solutions and challenges that we face as we modernize the NAS, as we move forward, and put in new technologies like Internet Protocol and other capabilities that also bring with it great benefits, but also inherent risks as we start to move forward. So I have, in the previous life, contributed to some of the cybersecurity issues we're going to talk about today. The inherent risks that we see sometimes with bringing these forward have not been ignored, though. There has been a number of proactive activities within the government, the FAA, and contractors that we've addressed so that we are taking the appropriate vigilance and caution as we move forward with these new technologies, but we don't want to impede our ability to progress. And that's what we really need to focus on, is to make sure we can modernize the NAS, but do it with the safety critical nature of these aviation-grade networks in mind. So with that, I'm going to just ask the team to do a quick introduction across the panel, and then we'll start with some questions. So, Joe.
Thank you, Kelle. Appreciate it. Great to be on the stage again, back at RTCA. Thank you, Margaret and Andy. I really appreciate it. My name is Captain Joe DePete. I am a captain for a cargo airline outfit here in the United States by the name of FedEx. I have been flying for 37 years, and I serve presently right now as the first vice president of the Airline Pilots Association and also as its national safety coordinator, which means that I'm in charge of all the safety, security, and pilot assistance programs that we have at the Airline Pilots Association. In addition to that, I've been a line check airman for many, many years. I also serve as the PAC treasurer, so quite a few different divergent type of duties. And just happy to be here, and I appreciate the invite. Thank you.
All right, good afternoon. My name is Jens Hennig. I'm with the General Aviation Manufacturers Association. The reason I'm on this panel is that I had the pleasure of chairing what was called the ASISP working group. And ASIP stands for Aircraft System Information Security and Protection. It's a term that the FAA has started coining to take the overall issue of cybersecurity, which has many different sides to it, and narrow down and have a conversation about how do we maintain the safety and security of the aircraft, that specific problem. They tasked us with that issue spring of 2015, and we met between June 15 and August of 2016, and there are now 30 recommendations to the agency that we provided. Some of them have gone to RTCA, and our expert here on the group on that is probably Dan Johnson, who you'll hear from here a little bit later. There's an RTCA special committee that's dealing with some of those recommendations with respect to the standards, but there are other ones tied to CNS TSO documents, so the standards for how we build the equipment. And also, as any good rulemaking committee, there are some recommendations to the FAA about how to write rules and manage those standards going forward. So as we get into the questions, I'll use this term ASISP a little bit here and there and dive into some of those topics.
Thanks to Margaret and the group here at RTCA. They're doing wonderful work as usual. And it looks like I'm the lone federal guy on this panel, so I guess I'll be taking the darts. I will tell you that I've been doing this about 5 years after 3 government careers ending up in this one. About 2012, I was tasked by the Department of Defense to start looking at the security of next-gen and the future air traffic systems and ensure that we were infusing security into that infrastructure. 2012, I was thrown out a lot of windows in DC because I raised some vulnerability issues. It wasn't a real warm and receptive audience at the time because we had an impression that the NAS and air traffic systems really weren't vulnerable. But I will tell you, we've made huge progress in the last 5 years. Strange things have happened to me. I get invited to places like the White House now to talk about this. We briefed the President's cyber advisor. We briefed the National Security Council quarterly on the progress we're making. And we've created a cross-government team, with the Homeland Security, Director of National Intelligence, the Department of Defense, and Department of Justice, helping the FAA and Mil Civil Aviation. A lot of the work you've heard from Jen's ASISP is at that standards level, which RTCA, Dan Johnson, some of my friends here are doing a great job. We think at the federal level, we need to align the policies, the strategy, that national guidance. We're not going to build the solutions, but we've got to give the federal agencies the right direction and the right authorities to handle these issues. So that's what I've been focused on the last couple of years. We're trying to stay out of industry's way and provide good, coherent guidance down to bodies like RTCA, and then we're also trying to do some live experiments and testing of platforms.
I'm Daniel Johnson. I'm with Honeywell Aerospace, a cybersecurity fellow at the Advanced Technology Group. My main claim for fame here is that I'm co-chair of Special Committee 216 for the RTCA. We've been publishing standards on type certification of aircraft for cybersecurity. DO326A, DO355, DO356. Currently, we're updating 356 now that ASISP has come out and with all these recommendations. You made work for us, but I guess that's a good thing. I've also been involved with most of the cybersecurity certification efforts within the Honeywell organization as well.
Well, thank you. It's an honor and privilege to be here. I'm not an aviation expert, to be honest with you. I'm a cyber evangelist, although I fly 120,000 miles plus per year. Just flew back from Boston last night, but I'm a previous nuclear submarine officer. And when you think about it, nuclear submarine is really like an aviation platform. It's a wing, although operating at 21 knots as opposed to the higher speeds. And so with Raytheon, I'm a corporate vice president. I focus on cyber activities across the company. We've invested heavily in it. We've bought 19 companies over the last few years, rounding out our portfolio with very unique intellectual property and products, which I'm very, very proud of. I also have the honor to serve on the CANSO Aviation Security Working Group under Director General Jeff Poole. We launched that a couple years ago. It's a global organization. We published the Aviation Security Risk Management Guide, which is purely cyber, and it really got buy-in around the world. It so happens I'm the only U.S. representative on it, which is kind of interesting. The rest come from all around the world. I also serve on the ATCA Cybersecurity Committee, and of course, ATCA has their cybersecurity conference next week, and we'll be launching a very unique white paper as well. It will be published, so please look out for that, and working with Paul Plancer and some of the other leaders from ATCA. So again, it's an honor to be here, and I welcome the open dialogue.
Great. So thank you, everybody. Just to kind of ground the conversation today for the panel, cybersecurity is a pretty ubiquitous term, and most of us think about it as the viruses or stealing of credit card numbers. So I'm going to ask the panel, maybe Dr. Johnson, if you could expound a little bit on what's relevant in the cybersecurity realm with aviation today.
Okay. Well, my focus is the aircraft itself. And the focus there is largely safety. Cybersecurity is a source of additional adverse events that can affect the safety of flight of an aircraft. And so, yes, we're very concerned with that. We have, I hate to call this an advantage. We have an advantage in that we're old technology. And so we haven't connected our aircraft out to the world except in limited fashions. But the world wants to be connected to us, and we want to be connected to it. And so we have the opportunity here to do it right. We also have the opportunity to shoot ourselves in the foot and cause even greater security problems. So largely, our goal is to try to make sure that as we enter this world, we do a proper job of it.
So pulling on that thread a little bit, there is obviously, as part of the next gen programs, the pull to really modernize the technology. Are we opening ourselves up to additional vulnerabilities and attacks with those new capabilities coming into the NAS?
Well, in a sense, of course. Security is discrimination. So you open the door to let people do additional functionality, and you suddenly realize that there are bad guys out there who can use the same door, so suddenly you have to put locks and keys and so on. Unfortunately, with connectivity, current technologies, it's real easy to do the connection part. It's not as easy to do the security part. And as we open up the ATC to new levels of connectivity, that discrimination function will need to happen there too. Right. But I believe that if we can do that discrimination properly, we will not be opening ourselves up. But we have to do that correctly.
You know, if I could comment. You know, I think that's a really good question because, you know, for the most part, much of the new technologies are really assistive for pilots because we get these really great, robust decision-making tools, right? We get increased situational awareness, which leads to better safety, but it's a double-edged sword. And now we have multiple pathways of connectivity, right, that may have some vulnerability. But what I'm really happy to see is, you know, I've seen this, like I said, I've been flying for 37 years. Part of that was in the Marine Corps, by the way, so I'll lower the bar right now in case I say anything really bad. But, you know, it's changed so much from, you know, there used to be a pretty strong divergent view about people who believe that there were vulnerabilities or possible vulnerabilities to what we see today. And today I see much more, very positive, much more collaborative effort towards this and a commitment on everybody's part to, you know, to also from the standards point of view, which I know you're going to get into a little bit. But I can remember a day when I used to get on an airplane and I could literally, especially as the captain, it was the greatest job. I'd get on and say, you know, I'd pre-brief everybody. I'd get on the airplane. I'd flip a few switches. I had a very reliable source of information coming into the airplane. I had my flight plan. I did my brief inside. I'm going to talk to somebody on the radio. And that was it, pretty much. It was old, you know, old technology, and off I went. Now I'm kind of programming for a while. You know, I get out there early. We're doing a lot of programming. But good point.
Yeah.
When it comes to next gen, though, the core of your question here, it's important to remember that we're not turning off the old system. There seems to be big confusion out there that you're either going to be space-based ADSB or radar, and I'm talking about the conversation that occurred this morning. That's not the case. It's an evolution within the CNS environment. And one of the reasons that we're keeping the older systems is the belts and suspenders approach that we have in aviation. So for nav, yep, I'm going to be using GPS as my positioning source, and the general aviation industry has been doing that quite successfully now for about a decade and a half, going on 2 decades. But if everything fails, spoofing and jamming does occur, especially by the people that employ Steve out west. I return down and fly off of VORs and other technology. Surveillance, yep, I'm going to use the satellite-enabled positioning source, but that doesn't mean that I'm getting rid of either secondary surveillance radars or the primary ones if there's a problem with that system. Datacom, you're still going to be able to talk voice comm if there's a backup. So I think some of the excitement that's out there next gen is really, really dangerous. Let's calm that down a little bit because we are doing an evolution off of existing technology in a smart way. One of the recommendations that came out of the work that Steve and Dan and I did is to ask the FAA to take a look at the aircraft component of the CNS technology. There are a number of standards, many of them held up by RTCA, that the FAA point to through what's called technical standards orders. One of the recommendations that was given to the agency, and they've started the work with several of us in industry, to say, let's take a look at each one of them and see, is the right requirements allocation when it comes to cybersecurity the aircraft, or if we look at the aircraft in context of the legacy technology, we don't need to do anything to the aircraft because we have sufficient backup. If there is something that should be done to that datacom capability, for example, especially when we start plugging into the FMS, let's start that work now.
So let's move into dangerous territory a little bit. And I'm going to ask Jeff, our cybersecurity expert, because he probably has more visibility into those kind of offensive capabilities. What do you see? We talked a little bit previously about you're only as strong as your weakest link. What are the kind of things that we do need to be worried about and that we're aware of that we need to address so that we do have a resilient system for the NAS?
Well, what I'd like to do is continue to build on the other comments made and discuss next-gen as one example. And when you think about it, as you evolve to a system-of-systems architecture, many of the subsystems that are designed, developed, and produced by different countries, different companies, many of which may have very different standards. Do they have the same supply chain risk management processes we have to minimize exploitation vulnerabilities in hardware, software, and firmware? Do they have the same software development requirements we have to minimize exploitation vulnerabilities in code? Because traditional writing of software imparts significant exploitation vulnerabilities. We have a process that is almost identical to FedEx. FedEx will tell you that they can eliminate 70 to 80% of exploitation vulnerabilities in their software because they have a culture. Before that first line of code is written, it's to minimize exploitation vulnerabilities. We have a process we call Raytheon Assured Software Program that's almost identical. And what you'll find in industry is they'll say if you use a traditional software scanning tool, I'm not going to mention names, you may identify 30% of the exploits. That leaves a huge attack surface, huge attack surface. But the point is, when we evolve to a system-to-system architecture, you're only as strong as your weakest link. The perpetrator will find their way in. It's kind of analogous to migrating to the cloud environment, right? I mean, people think that if I migrate to the cloud, I can be much more secure because I have a minimal attack surface area to protect. But should someone penetrate it, they could have access to everything. And that's why it becomes increasingly important to implement a multi-layered, multifaceted approach to cybersecurity in any system so you compartmentalize it. If someone gains access to a portion, that's all they gain access to, not the entire system. In the financial world, same things apply. You know, there are certain assets they just absolutely want to protect, and they'll invest more in that. It's kind of aligned with this whole issue of cyber resiliency. How do we maximize mission success and retain operations when we're under attack, cyber attack? Cyber resiliency processes are the same regardless of what the critical infrastructure is. Transportation is one of our 16 critical infrastructures, defined by the DHS NIP, National Infrastructure Protection Plan. But the priorities are different. In the aviation industry, priorities are minimizing risk of loss of human life, in my opinion. The financial industry, it's minimizing risk of loss of money. In the military industry, it's minimizing risk of loss of the warfighter on the battlefield and to achieve our mission. But it's really all the same, but the priorities are very different among and between the business and the infrastructure. Also some other comments about some things that have happened in Washington that I think, if you're not aware of it, I think you'd be very interested in relative to things like the President's executive order. Thank you.
Sure. Steve, you've talked to us about some of the proactive measures we've already taken to kind of balance the caution we need, but with the modernization of technology. Can you expound a little bit on some of the things we've done in the projects that you've undertaken and implemented from that perspective?
You know, first of all, it's become teamwork. You know, that's critical, that we have to address this realistically as a team. When we do that, we can influence things like the FAA reauth. So it has language in it now that mentions these topics and devotes some research money, like the new executive order out of the White House. We had a chance to influence the words that were in that. We just came out of rewriting the National Strategy for Aviation Security. I don't even know if people knew it existed, but it was penned in 2007. And it specifically had a sentence that says, cybersecurity and unmanned aircraft are not included in this strategy.
Wow.
We just fixed that. It was a very painful process. If you've ever edited a document with several hundred people, oh wait, you do that all the time. It was very painful, but we got a lot of good inputs from a broad cross-section of industry and government. And I think you'll be really proud when you see that strategy. It accommodates the future, and it provides that national level guidance. That's now propagating down into the departments where they're standing up initiatives, they're getting resources. DHS just brought on another about 20 people to begin looking at airports, RF links, fuel trucks, these types of things. And there's teams out there today evaluating that infrastructure. Not to give anybody a bad report card, but to understand the status of the existing environment. And then that's being turned over to the DHS, they call it National Cyberspace Coordination and Integration Center, where they have teams of people that have been securing power plants, nuclear power for years. So those experts are now turning an eye to aviation. So we're capitalizing on what they've learned in the financial industry and these other industries, and we're accelerating that very rapidly now. I think the next step is to get the right levels of budget and to realign these policies. We did an inventory of policy across federal government that we completed in December. Went in to brief the President's cyber advisor, Mr. Michael Daniel at the time. And we said, well, sir, we've found 180 formative documents at the national level that guide security or aviation cybersecurity. We did narrow down to just aviation. And he said, oh, and you want more? And we said, no, sir, we're going to recommend that maybe we take a look at these and cull and synchronize that guidance. Because at the moment, a law enforcement person may be put at odds with a defense person. You know, a cyber crime, they want to preserve the crime scene. In the meantime, the DHS folks want to come in there and catch the bad guy. So those are at odds with each other at the moment. Right. So those are some of the activities going on. We can share a lot more info about that with the group. If you'll Google a thing called Aviation Cyber Initiative, that pretty much codifies this. It's a task force agreement that was signed about 18 months ago. We're in the process of re-signing that now at the secretary level. So that will be aligned with the new cyber policy as well out of the White House. So hopefully I'm relating to that there's a lot of work going on in the government now. And then through the Aviation Government Coordinating Council and the Associated Sector Coordinating Council, that info is propagating down to industry. We're also peeling classifications off of many of these things.
Right.
At one point, we couldn't say anything. Well, now we can talk pretty openly about a lot of what we're seeing. An example, Dan talked about connectedness being a problem. A lot of the malware that we've been finding in the Department of Defense lately doesn't need connections. It specializes in what we call air gapping. So a lot of the recent vulnerabilities we've found get on maintenance laptops or devices when we upload data. Now, in theory, you have to connect to something, but we don't have a lot of these devices connected, and yet they've got tons of malware on them. So those are other types of things we start to think through.
It definitely feels like, because we've been more in a legacy technology and closed network situation, that we've had some inherent protections. It's interesting we talk about the aircraft, but you've also just talked about a lot of things we're doing with the actual infrastructure. Yes. So the infrastructure is definitely a piece of the focus.
Infrastructure continues to be a piece of the focus. In fact, DoD has always thought for probably 3 decades of the aircraft as a node in a network. Everything is actually in some way connected. Even disconnected things are connected when we load data, when we do software patches or those kinds of things. So you have to kind of think of the ecosystem, and we have coined that term now. We stopped using the word NAS because to some people like air traffic, that meant, the air traffic. Really, we need to look at that entire ecosystem. So you'll find that in the National Strategy for Aviation Security now as the favored term.
Very good. Jens, do you see similar concerns and progress with general aviation as you do with kind of the major air carriers?
It's fair to say that the approach to securing the aircraft is very similar. The FAA has a mechanism, I don't know if people have come across, it's called a special condition. It's basically when the agency approaches a new topic, it's been many over the years, how do we certify against lightning? How do we deal with new types of batteries and so forth? The FAA does not today have a rule that says how to deal with cybersecurity for an applicant, be they in Joe's world with air carriers or in the GA world. They have a policy that lays out when they will move forward with it. And it's simple to say there are several triggers: connecting the aircraft to the internet, having certain other indirect connectedness, the air gap conversation that Steve just had. Those kind of things are laid out in this policy. If you're a manufacturer and you design a new aircraft or you do a type design change, the FAA will look at that application and say, where do you fit on this policy? And you will either be triggered a formal special condition, which is basically a rule applied just to you with a lot of technical background behind it, or they might work with you in a little bit more informal way. The special conditions that the FAA has issued over the past 7 or 8 years since the first ones came out, there are Airbuses, there are Boeings in that list, but there are also Gulfstreams, Bombardiers, Dassaults, Embraer and other models in there all the way in through the GA space. There hasn't been a specific special condition issued on a small airplane just yet. These aircraft actually have fantastic connected capabilities, but they tend to be managed more directly by the aircraft and avionics OEM. A GA pilot is not going to have an ops center that makes sure that their iPad is kept hygienically clean from the problems. We're going to assume that the person flying his or her Cessna, Cirrus, or Piper grabs the same iPad that they watch Netflix on for purpose of their charts. Sure. And the manufacturers have looked at that, and we have that capability in many connected systems today already. So it's just looking at the problem, and the key thing is the connection to the aircraft, and it's been addressed by the different OEMs and the avionics and equipment vendors.
Great. One of the things that Jeff brought up was the key tenet for aviation is obviously safety, but the other piece of it is efficiency. Are there concerns at the pilot or at other levels that we're going to compromise efficiency by having to put in structural things to help with the cybersecurity elements of things? Sure, go ahead.
Sure.
Go for it, Joe.
No, I actually think it will, to some degree it could be synergistic. First off, and I get paid to say this anyway, so I have to say this, that the most important safety component on any aircraft, any man, is a well-trained flight crew, okay? Which leads into, I don't see that we're that far off at some point, and I'd love to see it as part of the standardization process, that at some point that on my flight deck will be similar to what's in my computer, and that I'll have a McAfee, I like to use a word, right? Some way to monitor and detect for abnormalities on the aircraft so that I can manage that and have another set of robust tools to be able to, my responsibility every time we sign for the airplane, right, is we are legally responsible for the safe and secure conduct of the flight. So the more tools we can get to do that, I think the better. But I'm really encouraged by what, Steve, when you mentioned, this is the first time we've seen with the FAA's Extension Safety and Security Act of 2016, really relatively strong language, that basically says it calls for a comprehensive, strategic set of policies and principles against cybersecurity, to prepare for cybersecurity in a total system way, the total system. And you mentioned how important it is, as the Airline Pilots Association, certainly our main focus is the health and safety of the aircraft, okay? But, it doesn't take much. I mean, you talk about FedEx or any of the other big companies that have global reservation systems or global shipping systems, how devastating that can be if we have a problem. So I know I bounced around a little bit of it.
So I'm going to jump in here and maybe we'll get some fun disagreement on the panel.
Okay.
I spoke at ALPA's security conference a couple of months ago here in DC, and this policy that Joe references on the ALPA website was rolled out there, and I was challenged on some questions there about the role of the air crew in this cybersecurity world. And it's one thing that I'm still trying to get my mind around, and just for visual, I'm making an extreme example here just to make a point, so no offense here. I don't believe that enunciation should be a pop-up on the flight screen that tells the pilot, you've been hacked. I think that would be a terrible human factors consideration. That would be worrisome, and if that aircraft has a problem, historically, if I have a safety issue with the equipment, in GA I get a red X on the equipment that says it ain't working anymore, go back to your backup procedures. I would venture to say that seems to be working, and instead of confusing the flight crew, and I've been scratching my head ever since that conference, was saying you've been hacked. If there's a safety or security driven problem with the aircraft, again, Dan Johnson, our members, everybody, our goal is for that to never occur. We have good processes in there, right?
Excellent.
But if that bad scenario actually played out, is it easier to fit the security realm into those existing safety procedures so the flight crew finds out, red X, my whatever piece of equipment isn't working, but I know from time in simulators and elsewhere on how to deal with that. Land, after that, we figured out it was a hack in that scenario, and people who know how to run a malware system is out there. I mean, I don't want to have the flight crew trying to run malware on an approach into a big airport. That would be a very stressful environment, I would assume. I'm giving you a little bit of a hard time here, but that's what I took away from your conference.
Jen, I am not surprised that you said that. It's traditional pilot engineer thing that goes on ever since the movie The Right Stuff, right? We don't, fly the capsule?
Yeah.
We see, engines on fire. We train for all sorts of things. And along with these new technologies comes training. And, we handle pretty stressful events, Jen. You know what I mean?
I don't want to give
That's what we get paid to do. And,
don't want to give you a new one.
all we want to do is that's okay. We want to know. We're on the airplane. It's our ass, on the airplane. So we want to know. And we have passengers in the back to protect. I don't know if some guy on the ground said I didn't need to know that. So, for me,
that's a good dialogue. Do
I
we need
think there's
McAfee for pilots? I know both Steve and Daniel want to jump in. Is McAfee for pilots a good idea? It is. Your engine on fire is a big deal.
Well,
absolutely. Do you need to know your malware if there's nothing you can do about it?
I
Should
kind
it
of think
just
what you're
revolt?
hitting on is the human needs to be incorporated in this
In the loop.
decision-making process. And there's a whole human factors branch now looking at what is cybersecurity, how does a human perceive this,
Right.
what is the effect? Right now it's sort of nebulous. So to your point, yes, we need some way to notify the aircrew that the situation has changed.
Right.
We don't want to give them a nebulous indicator that they can't do anything about.
Absolutely. We have that all the time. We actually, as a line check airman, believe me, when I give sim rides or do some, we actually throw some distractions in there, and we want to see prioritization of issues, that are going to go on. Is he going to focus on the little yellow light or that burning engine out there? As he did everything right until that one point. We throw that one little thing in there, and he starts paying attention to something that shouldn't be paying attention to. I think there's a happy medium. But again, unless you're willing to put your name along the side of mine on the release that says you take full responsibility for that aircraft, I am entitled to know everything that happens on that airplane. And I will make that decision.
Yes, in fact, there is within type certification a regulation that says that if our equipment isn't working exactly the way it's supposed to, we're supposed to tell you.
We're supposed to tell you.
But there is also then a clause in some of the standards that says that when we tell you something, it should be something that's actionable.
That's real, right?
And yes, just simply warning that it's possible that this might be a dangerous website is not helpful.
Steve, we fly airplanes now that, they actually fix themselves sometimes. You get on the airplane, and I know we fly the 777 and everything, and the MD-11. And if a malfunction happens, we get a light up there. Human factors, right? This is all human factors. Okay, let it do its thing. It goes to a little sequence and isolates buses and does all that. Thing is knowledge is power. Okay, we need to be able to make strong, solid decisions based on what's going on in the airplane. That's all I'm calling.
And this is not a lot
There's a
different than
balance.
some of the stakeholder consensus discussions we've had earlier. Jeff, you wanted to add something?
Well, just a comment about aviation platforms and many other platforms. For example, many in industry refer to them as flying pieces of software. Take JSF, right?
Yeah.
It's a flying piece of software. What did you fly in the Marine Corps?
130s.
Okay, 130s. 130J? Or?
No, F models and R models.
Oh, okay.
And T models.
So think about this. There's a whole initiative in our federal government today to cyber harden major systems, particularly in the military, particularly in the aviation environment. But one question I always pose is, when you harden a system, what happens 2 weeks from now? The threat is constantly changing, randomly in real time. How do you maintain the cyber hardening component of that system? Is it like you're downloading additional software updates to your operating system on your home computer? Can you do that in real time to a major system, whether it's an aviation platform, whether it's a military system, ensure that it remains operational and certify that it will be operational? How do you continue to harden those systems and keep them such? That is a big challenge. You can take it through, as I mentioned, the whole supply chain risk management process to minimize exploits, secure software development process to minimize exploits, and when you field it, you think it's pretty darn secure. But is it still secure a week or two from now? That is a big challenge for all of us and a big challenge for our nation. You know, there are certain nation states that have significant cyber human capital. We have a shortage of 500,000 or so here in the US, growing at a double-digit CAGR. We have a shortage. How do you close that gap? Very, very difficult, but there are certain nation states, if they want to do brute force attack on any of us and apply 50,000 cyber professionals, they have the human capital to do so. And they're generally going to win. Whether it's aviation infrastructure, military infrastructure, financial infrastructure, doesn't really matter, whatever their priorities are. If you think about the intellectual property loss this country has experienced, and I have a personal concern with that, because it does have an impact on our economic performance and economic wealth. It's approaching $2 trillion in intellectual property loss. I had the opportunity to speak on a panel with Congressman Mike McCall, Secretary Chertoff, and a few others. McCall made some opening remarks, 5 minutes. His final comment was, why invent it when you can steal it? Those are his words, not mine. And his point was, we've lost over $1 trillion in intellectual property. JSF designs. China has launched something that looks just like it. And we have a level 3 technical data package to produce a system. And guess what? There was an error in our design. There's a rivet missing right there. And someone launches the same product in a different nation state. The rivet is missing right there. How would that happen? So, you know, all these are interrelated, and clearly as our defense guy here, you deal with this every day.
I noticed Dan was,
Daniels, yeah.
Yeah.
he was twitching there, so.
People forget that when safety became a big issue with complex electronic systems, we had the same trade-off issues between safety and efficiency. We've sort of settled on a lot of practice, so we've forgotten some of that. Security is safety in many ways. The system engineering discipline was developed because we had to do trade-offs. Security has to become part of that process. It has to be part of the trade-offs between efficiency, human factors, and so on, so that we can accommodate all these issues. I tend to be an optimist because when your job is to field systems, you have to believe you can actually do it. But the basic standard is to show that you have what you best believe is an acceptable security risk. And the standard also has to be able to say no. It also has to be able to say, you can't get an acceptable security risk, you can't build it. And so we need to reach that point.
I think that's very apropos. There has to be you would field nothing if you felt like you could close everything. And Jeff brought up a very good point. From a cybersecurity perspective, most malware or other attacks have a very short lifespan. And you can't always know a priori that they're coming. Steve, you had something you wanted to add.
So a little bit in this theme, part of devoting resources in this country is to research, right? And it's not always about evolving the current systems we have. We need to be thinking how we would design systems to be secure from scratch. We need to do that at the same time we're evolving the systems that exist. You know, a lot of our research gets classified pretty quickly, but some of the interesting concepts that we can discuss is, you know, patching is a perfect attack vector. So this idea that you sit there and go, oh, it looks like it came from Microsoft and it says I need a patch, click this button. Well, the Chinese have figured that out. I mean, and other countries have figured that out. That's an attack vector.
Absolutely.
So if you think in that construct, we're beginning to look at what we call just-in-time operating systems. Devices that are completely devoid of any software until the time of use, especially now that we've seen a lot of these advanced persistent threats. Yeah. Is that feasible in aviation? That's sort of a scary question. Your jet has no software. You know, you can't even get the food on time. How would you get your software on time? You know, you'd be held at the gate for a software load. But we're specifically looking at electronic flight bags, and can we actually wipe the device clean, put it in a very special condition, you know, something you can't replicate easily in the open environment, and then feed it trusted software, and then have it live only for a certain period of time, you know, the duration of the flight or 2 flights or something like that, or until someone violates a condition. You know, when you plug into the internet and surf something,
Right.
your software goes away. So those are some of the types of things. We are also talking with NASA. It's not fully vetted yet, but we're talking about something loosely called secure net-centric aviation communications. And it would be, if I had to paint a vision for 40 years from now and design this stuff from scratch, I would never use TCP/IP. I might never use any of the protocols we have today.
Yes.
I might design protocols from scratch that are innately secure. Mm-hmm. And then there's a middle layer in that research that's very interesting. Probably a lot of you have heard of the sale of spectrum. There's a new opportunity there that if we liberate some spectrum band, industry can pay for a new capability to replace that, and then they get the spectrum. Mm-hmm. We're doing that with radar.
Yes.
FAA is looking at moving those radars. There's the potential in aviation that we could identify capabilities we want to move and get industry to help create the solutions. So that is that secure net-centric aviation communication. It's pre-decisional. It's still in discussion with NASA leadership and DoD. But I know we're doing a lot of the key components of that in the Department of Defense right now. So.
And so that's futuristic, and I always like that. But looking at the current environment, less the futuristic, there are ways to maintain your EFB. There are ways to maintain your maintenance computer. Mm-hmm. As manufacturers today, we don't just sell an aircraft and then move away. We have a very mature process for managing the continued airworthiness of the aircraft. Fancy word for maintenance for all practical purposes. And the work that's been done and what the FAA has gone on the record of, that's been set up here by several people. Security is a subcomponent of safety. From the approach of what we're doing here, I'm not worried about your passenger reservation system. I'm not worried about your entertainment system and its movies not working on a flight. The passengers will be upset, but the aircraft is still safe. I want to maintain the safety of the aircraft. Today, I do that by issuing instructions for continued airworthiness. These aircraft that have been electronically enabled, as part of that guidance that was provided by the FAA and also the work that Dan has been involved with, is a requirement to produce ICA, and we've also expanded it a little bit, say, an additional procedures for how to maintain that aircraft. So it doesn't only talk about how you maintain the black computer box. Those additional procedures that you see manufacturers putting out there are instructions to the operators for how to maintain the maintenance computer. If you have some kind of other system that interfaces with the aircraft, there are additional procedures beyond the ICA that are now being established there as part of the special conditions. So there's a future state, but there's also a very pragmatic near term where we're saying the manufacturer must produce, and the FAA has an AC 119-1 that says, as an operator, if you have one of these aircraft, thou shalt comply with them, and you must follow the procedures. So that's how we're managing it a little bit in the near term.
There are some technical challenges, and it relates as well to this continuing cyber hardness, if you would.
Right.
From a maintenance viewpoint, the reason that aircraft have such a good safety record is because at least once every 10 hours, we double check everything. And we have made sure that we can detect everything that goes wrong. That's a problem when we come to security, because as we know, my PC could have had a botnet for the last 10 years, and I would never know. We need to fix that.
Yeah, that's a vulnerability.
And because, in theory, if we want our aircraft to be safe from security threats, we have to have this, we can check it once every 10 hours.
And that's the balance some of us have been talking about over the last 2 days. We've talked about modernizing this ecosystem. I like that you use the term ecosystem. And clearly, we have commercial entities that are moving a little bit faster than maybe we do as the government contractors and the government themselves. How do we keep pace? Can we keep pace? And how do we make sure? We're going to have to, right? But how do we, there's open source, there's Microsoft, there's the iPads. How do we, to your point, harden them enough so that is it still a 10-hour check? Is it a 4-hour check? How do we make sure that we are ready for some of this? Please, Jeff.
I'll give you an example relative to DoD. Office of Naval Research is interested, Navy is interested in exploring sock on a ship technologies. Does that make sense? I think it might. You know, our naval vessels have a significant amount of software. Why can't we allocate a small portion of it to manage as a security operations center, manage for the cyber threat on a 24/7 basis? And I'm not suggesting we do this, but you could do it on an aviation platform. You could have some small portion of that aircraft that would run a SOC, CERT, CCERT, call it whatever you want, but is managing the cyber threat on the platform to ensure the safety of the platform. What do you think about that? You're an expert.
I'm looking at the false alarm rate.
Joe wants the notifications, though.
Yeah. Currently, in order for us to be able to tell a pilot that something is wrong and have him trust us, we need to have about a 5% false alarm rate.
Okay.
Right now, I think network intrusion systems only detect 30% of their threats.
Yeah.
And I would say their false alarm rate is probably almost 95%.
Huge.
And so we need to fix that. If we can fix that, and we are in a very controlled environment, so in theory, we should be able to fix this, then yes, we need to do that. Again, we need some way to detect all this stuff.
I'd like to get Dan involved. I think there's some CRADAs that are coming to bear recently, you know, with a lot of the avionics manufacturers and some of the big airlines or aircraft manufacturers. Through those, we can connect you to some of the research programs we've been doing for the department. One of them is loosely called attestation, but it's the ability to embed in hardware or software some known condition, some reference that's almost impossible to change. And then the box can always refer back to that. So if you violate any rule, it sort of reports itself. It may not have an answer. It may not be able to say what has happened, but it will say that I'm different than I was. At an aircraft level or a supply chain level, we're starting to build electronic copies of our aircraft. So I have a virtual copy of the aircraft that lives in a simulated space. And then every time the aircraft lands and I dock it, I can compare those two. And I can say, well, it left looking like this, and it came back looking different. At a minimum, I know something has changed, and I can begin to look at it. Right. So there is a lot of research in that area. I don't think any of it's ready for immediate prime time, but we need to start sharing those research programs.
Joe, you had some comments for...
Yeah, I just want to address the one issue about this concern about pilots being freaked out by lights. You know, I just want to, let me just get something squared away here for a second, okay? Okay, we are risk experts, all right? We've lowered the risk, right, with the data collection efforts that we have. We've lowered the accident rate. We're this is the safest form of transportation in the world. I mean, lowered the accident rate by 83%, commercial air safety team. The things we know, you know, a captain isn't God anymore. He is a part of a team, okay? And we're, you know, cockpit resource management, right? We threat error management, all those kinds of things that we're trained to do. Not every light we see in the cockpit, right? Some of them are advisory, and it gives us insight into where our prioritization lies. That's where our training comes in, all right? But, you know, I mean, ask yourself a question. Why does an airplane take off and hit a flock of birds and land on the Hudson and everybody lives, and yet there's another crew that takes an airplane and it's perfectly good and there's nothing wrong with it, and they lose the airplane through some kind of loss of situational awareness or a lack of training or something like that. And it all really comes down to the human factors issues that we're talking about. But trust us, we do this for a long time, and there is a reason why it's so successful, why I keep harping upon that pilots are a fundamental resource to use in trying, as part of this collaborative effort. But we can't do it alone. We can't do it alone. But if you give us something, sometimes you give us stuff that doesn't work. I got to tell you. I mean, there's plenty of things I've seen and gone, I know what they're trying to do there, and it's just that thing again. But it does heighten our awareness, and we say, okay, we know what that probably is, but let's look for secondaries. And you know, if it's a navigational error, I would like to know that the possibility is that it wasn't something, you know, even today, like when even though we have the airplane may turn, believe it or not, we have a chart out, you know, and we will manually mark that turn after 5 minutes just to make sure that airplane is exactly where it thinks it is, and we agree it should be. And so, yeah, we're part of this team, folks. I just want you to tell them we're trained to do this. And it's come a long way.
Pull with the Airline Pilots Association? Are they engaged? We get the
we're
the pilot and engineering piece, but with all the standards and elements of things, their voice must play a role.
Yes, though sometimes we can use more operators on a lot of the standard committees.
Right.
I mean, it's a fair financial investment to arrange to have somebody to go to all these meetings, so they tend to come only when it's really critical. But typically, that's the hardest sector it is to recruit that I found.
So part of the safety team that we have air traffic services that works together. You know, we're on a lot of RTCA panels. We've got aircraft design and operations specialists, 410 volunteer pilots backed up by a full-time engineering staff. Some of them are here today. Human factors and training group, airport and ground environment, big issue. And since I know we're running out of time, can I do one little pitch?
Right ahead.
I got to do my pitch, okay?
I know, I've got you.
So out of respect for my friends at RTCA, the Airline Pilots Association decided to unveil for the first time publicly our cybersecurity white paper, which you will find somewhere in the back of the room and also online. And Dan, I think you're quoted in this. I think we quoted him in there. But, very good piece. You may want to read it. Thank you.
No, absolutely. And it's interesting as we talk about this today, certainly the ecosystem commentary has stood out. One of the other things we've talked about is in my previous roles in kind of the surveillance and intelligence worlds, Internet of Things was a big element. And every point of connectivity was a point of opportunity, offensively and defensively. So Jeff, I'll ask you for expound a little bit, because I know this is kind of your area and your domain. Do we have a good grasp on everything we need to take a look at? I know it's a lot, and I know it changes daily, but...
well, the botnet threat was just brought up a little while ago. The advanced persistent threat was brought up a little while before that. When you talk about the cyber attack vectors, they really haven't changed. They've just become a lot more sophisticated and stealthy. Whether you're talking about zero-day phishing schemes, botnet, APT. But what I'm concerned about is in the cyber ecosystem. There are two things that concern me. One is the black market for cyber attack tools, which a lot of people don't think about. How many in the audience are computer scientists? How many are electrical engineers? You don't need to be a sophisticated software developer today to buy a cyber attack tool on the black market. And the more you pay, the better tool you get. So that's an issue. The other issue is the Internet of Things. And how many in the audience are somewhat well-versed in the Dyne attack of late last year? You read about it? So it was a DDoS attack that occurred to a major company, took them down to their knees. Now, how did the DDoS attack occur? It leveraged compute power in baby monitors, Wi-Fi enabled heating and air conditioning control systems, smart televisions, smart refrigerators, beyond computers, where it's harnessing all this computing power and infusing it on something that they want to deal with. One of the concerns I have about the aviation industry, quite frankly, is the ability to harness that kind of information from a DDoS perspective, distributed denial of service, and impact the entire communications infrastructure associated with the aviation system. I don't know how you feel about that, but it certainly has a concern relative to me. You saturate the bandwidth associated with the communications infrastructure so they potentially can't operate.
This is actually an important point, particularly when we look at security assessments, is that the current system is actually designed so that pilots can land without any ATC. I mean, GA planes now regularly have radio failures and they have to be able to land anyway. But as we connect more strongly with ATC, and as we decrease separation divisions and all of this, that's going to erode. And so whereas previously we had a situation where an ATC under attack, the pilots themselves can take it on themselves to land safely, we may lose that. And that's very scary.
Which is kind of interesting, because as we talk of, all the things pilots can do, I am a pilot too, but I'm not as good as Karen. We're also rapidly trying to design aircraft without pilots. When you combine cyber and removing the pilot, I'm very afraid.
Yeah, we didn't touch on drones, and we don't have a lot of time. I won't go to it, but the drone element, we heard a little bit of it in the UAS XCOM panel. Counter drones,
Almost
what you
everybody
do,
designing
worried about things, absolutely. One
almost
landed on the White
everybody
House
designing
lawn,
something
right?
to be cyber secure these
Right.
days realizes there has to be one manual component left in the system.
In the loop, absolutely.
And that manual component is usually controlled by a human.
Yes,
So
Pete's on board with that.
A remote pilot.
We talk about that, and we didn't have a lot of opportunity today to talk about drones. We've got just a minute, but we've talked about the fact that a drone a few years ago landed on the White House lawn. They've become much more sophisticated, and you can buy these things fairly cheaply. And the day that an IED or some other kind of event, comes from a drone, it's another element of this that, from a cybersecurity perspective, it's not just detect and avoid so we can have them cooperatively work in the NAS. There's what else do we need to do to make sure that they're not going to be a threat to anything in the NAS. So that's going to be another
2012,
dimension.
There was a drone Olympics on the West Coast for drone hobbyists. The winning entry was an airborne virus propagator. It would fly up next to other drones, infect them, with the intent of creating a coordinated swarm, but that part quite didn't work, so they just crashed. But yes.
Wow. Maybe on
And that
note,
was 5 years ago.
things are moving very quickly again. Do we have any questions from the audience? We're working on the mic. No problem.
We were just under a cybersecurity attack, which is what brought that mic out. Yeah.
Illustrated for purpose.
So you haven't had the opportunity to answer and to respond to any questions, and I would invite you to just address the cyber side of it from the ground infrastructure that's supporting aviation before you close.
Sure, absolutely. From Harris, we have a lot of the next-gen programs, including the federal telecommunications infrastructure pieces, the next-gen voice switch, and certainly ADSB and other elements of the next-gen programs. We're moving from TDM to IP. TDM, as we talked about, has some inherent point-to-point capabilities that allow it to be a very closed network, and it provides us and affords us some opportunity to not have to worry so much about the cyber. And as we move more towards IP, and I talked about some of the kind of the Internet of Things, every connection point you make, Daniel kind of underscored this, as did Steve, every connection point you make is an opportunity for somebody to inject something. And that's where we really need to be vigilant as we move forward with the next-gen programs to ensure that we have that safety and efficiency at top of mind, but we have to really be vigilant about cyber attacks and what they could do and how they interrupt. They change daily. It's going to be a very complicated effort. This will be something that we need to address for the long haul. What I'm very pleased about with the panel today is we had a lot of consensus that this is a big deal, that people aren't, we don't need to worry about that. It's not something we're discussing. And I think it's just something we're going to have to stay on top of and do more of. I'm glad to see so much research and proactiveness already. I thank Margaret and RTCA for the opportunity today from the panel, and thank you so much to my esteemed colleagues on the panel.